Okay, so for this problem, it's a two-part problem. And for the first part of the problem, they want us to find the velocity of the cars right after the collision. So what we're given is the mass of the car going east is 1,500 kilograms. We know that the mass of the car going south is 1,800 kilograms. We also know that the velocity of car going east is 17 meters per second, and the velocity of the car going south is 15 meters per second. The second's a little cut off in the video. But using momentum principle, we know the momentum of the car going east, and we know that we can find the momentum of the car going south. So we're going to find the momentum of the cars after the collision. So we're going to let both the cars move with a speed v at the angle of theta to the south of east, because we have a car moving east and a car moving south, so we're going to let them go move at south of east. So therefore we know that the momentum of the system in the east direction after the collision is right here. And we can use the conservation, well, we'll get to that in a sec. So right here you can see that we're doing the same thing with the momentum of the car going east as we are with the momentum of the car going south. We're trying to find the momentum of the car going south. Well, now that we know it, we can use the momentum, the conservation of momentum, to find these two values, to find the velocity of each car after. So we're using the conservation of momentum right here to find, we're basically just rearranging after right here, and so we know that v cos theta is equal to 7.73 meters per second. That's the velocity of the car going east after the collision. And then we use the conservation of momentum on this car going south right here, and we rearrange it, and we know v sine theta equals 8.20 meters per second, and we know that's the velocity of the car going south after the collision. So what we need to do is we need to throw them in the Pythagorean theorem to get the magnitude of the two. So we take those two values we found just now, the momentum, the v sine cosine theta for the car going east, and v sine theta for the car going south, and we take the value that they're equal to, and we get the magnitude, velocity equals 11.27 meters per second. And that is how fast the cars are going right after. Now we need to find the angle, right? So we know that tan theta, we can use these values for v sine theta and v cosine theta. So we just put the values in for what we found on the last page, and we get 1.06. Well, we just need to do tan inverse to find the angle. So we know that both cars are moving at 11.27 meters per second at 46.70 degrees south of east. And that's right after the collision. So that's the answer to part A. Now for part B, they want to find how much kinetic energy was converted to another form during the collision. So we know that the initial kinetic energy of the system is this because we use the formula 1/2 times mass times v squared, and we can use that to get the kinetic energy of the system as a whole, because this for the energy for the car going east, and this is for the car going south. And then we can find by using the same formula, we can find it going after the collision, and we get that, and all we have to do is get the change in kinetic energy, which is kF minus Ki, and then we get 20,000 or 209,678.715 joules, and that is the total kinetic energy converted from another form during the collision.